Okay, let's get the B part of this question. Draw the 110 plane and calculate the atoms per square centimeter on the plane if the lattice constant is 4.05 Armstrong and the plane belongs to FCC, face-centered cubic structure. Calculate the inner planar spacing between the plane 110 above. Okay, let's do that. Whenever you come across something like this is simply what your Miller indices. First thing first, they said we should do what? We should draw the plane. We should draw this plane. So we represent it, since we are dealing with a cubic structure, then we represent it in our X, Y, and Z axis. So let's do that. How are you? So let's call these parts our Z axis. And these other parts are X axis. And finally, this is what our Y axis. Now, our Miller indices given was what? 110. You don't write your Miller indices as 1, 1, 0. So don't do like this. This should be very wrong. This is very wrong. Now, you know that for this, we take our lattice constant to be unity. That is, from this point to this point is 1. From this point to this point is 1. from this point to this point is 1, right? We take our lattice constant to be unity. And here, comparing it with our axis, we know that x is what? 1, y is what? 1, and z is 0. So for anyone that is having what is 0, our line to be drawn should be parallel to it. So let's connect those with 1, 1, with unity. So we are having x, 1, right? X, 1, and y, 1. So we go over to this point, we connect it to this point. We've connected that. Let's go over to the upper part of it. We also connect what? The x-axis to the y-axis. These 2 points. Mind you, it is parallel to the z-axis because the value for z there is what? 1. Is 0 rather. So let's do that. Let's connect it. This to this. Okay, that is that. So mind you, the thickened part gives us our plane for these Miller indices. So our plane looks like this. Which is parallel to our z-axis since our z-axis has no value. So that is the plane. That is the plane for the given Miller indices. Next up, we are asked to calculate the atoms per square centimeter on the plane. If the lattice constant is 4.05 Armstrong and the plane belongs to FCC, phase center cubic crystal structure. And finally, we are asked to calculate the inner planar spacing between the plane 110 above. Okay, let's do the next one. The atoms per square centimeter on the plane. If the lattice constant is 4.05 Armstrong. Now, to calculate the atoms per square centimeter on the plane, firstly, we calculate the area of the unit cell in that plane. So let's calculate the area of the unit cell in the given plane. Now, we are given our lattice constant A as 4.05 Armstrong, which is the same thing as 4.05. Now we are converting to centimeters since they want our answer to be in centimeters square. So we have what? 4.05 times 10 raised to power minus 8 centimeter. Now recall that for an FCC structure that the diameter is given as a root 2. Therefore, our diameter becomes what? 4.05 times 10 raised to power minus 8 multiplied by what? Root 2. Therefore, we have that our diameter is equal to 5.69 times 10 raised to power minus 8 centimeter. So let's calculate the area of the unit cell in the 110 plane. Area d square. Area. So how do we calculate for that? We simply say area of the unit cell in okay, we've gotten what? The diagonal. Remember, we are asked to calculate for the atoms per square centimeter on the plane, on this plane, just this plane. Yeah, on just this plane. And mind you, this is our diagonal. And we know that for an FCC structure, the diagonal is given as a root 2. A root 2, where a is our lattice constant. So after getting our diagonal, the value for our diagonal, we then calculate for what? The area of the unit cell. And we had that our diagonal is what? 5.69 times 10 raised to power minus 8. Also, we also know that this still remains our lattice constant A, right? Which is equal to what? 4.05 times 10 raised to power minus 8. Right? Okay. That is that. So to calculate the area of the unit cell in this plane, we simply say what? This multiplied by this. Right? So what do we have? 5.69 times 10 raised to power minus 8 centimeter times 4.05 times 10 raised to power minus 8 centimeter. And this gives us 1.468 centimeter square. Right? That is the area of the unit cell in the 110 plane. So next up, we calculate the atoms per square centimeter. Atoms per square centimeter simply becomes, for an FCC structure, we know that the atom is what? 4. We get what? 4 atoms, all divided by what? The area of the unit cell in the 110 plane, which is what? 1.468 centimeters squared, and this is what? Your 4 atoms. Therefore, atoms per square centimeter becomes 4 divided by 1.468, and this gives me 2.72 atom per centimeter squared. So that is your answer for that. The next question says, calculate the inner planar spacing between the plane. Calculate the inner planar spacing between the plane. So how do we calculate for that? Calculate the inner spacing between the plane 110. So the spacing between the Miller indices XYZ or HKL. So let's take the XYZ or HKL lattice is given for cubic as 1 over d squared equal h squared plus k squared plus l squared, all divided by a squared. The spacing d between adjacent xyz or HKL or xyz lattice plane is given for cubic as this. So where we take for our Miller indices that our h is 1, our k is 1, and our l is 0, depending on the plane given actually. But for this plane, we are given what? 110. Therefore, h is this, k is this, and l is this. So let's just impute that there. Where a was given to be what? 4.05 Armstrong. HKL, as I said earlier, are the Miller indices of the plane 110. So let's impute that, where h equal 1, k equal 1, and l equal 0. So let's put values there. Putting values, we get that 1 over d squared is equal to what? 1 squared plus 1 squared plus 0 squared, all divided by 4.05 squared. Therefore, 1 over d squared is equal to 1 plus 1 plus 0, all divided by 16.4025, and this gives me 2 over 16.4025. So what would that give us? 1 over d squared, right? So let's cross multiply, making d our subject of formula. What do I have? D times 2. 2d squared is equal to 1 times 16.4025, 16.4025. Therefore, d squared, dividing both sides by 2, we get the value of d squared to be 8.20125. Next up, we take square root of both sides. Taking square root of both sides, we get that d is equal to the square root of 8.20125. Therefore, d equal 2.86 Armstrong. So that gives you the inner planar spacing between the plane 110. This 2.86 Armstrong. And in converting that to your meter, you have what? 2.86 times 10 raised to power minus 10 meter.